suppose that you're a patient, like you're like in a medical patient thing, not a patient person, and you are on a drug or medicine regimen. So when you take a medicine, so this one it says you start with 300 milligrams in your bloodstream. So like I took cough syrup this morning, and you take the medicine, and over time it wears down, it wears out of your system, and that's why you have to take another dose. So this particular medicine is eliminated from your bloodstream at a rate of 20% every hour. Okay. So we're going to write a function to talk about how much medicine is in your bloodstream. So let's start, f of x. Now, what is the initial amount of medicine in your blood? 300. All right, so I used the 300. Now, is this medicine increasing or decreasing in your blood? It's decreasing, so we're going to use this 1 minus p formula here. We're going down by a percent. So I'm subtracting off 20%, so you would think 1 minus 20%, which would be what in your parentheses? 0.8. Now, you are more than welcome to write 1 minus 0.2 in your parentheses, but I'll always write it as 0.8 when you see these. Okay? Easy, not hard. You can write that model. Now, use a graphing calculator to graph that function. So we're going to type in 300 times 0.8 to the x. And since we've changed our windows a couple times here, when you type that function in, make sure you hit zoom 6 so it goes back to your standard grid. We want to start from the basics. So type in your equation, hit zoom 6. Make sure you can use your calculator here. Now on zoom 6, can you see the picture? No. Well, what is the y-intercept of this graph? 300. Now, is it increasing or decreasing? It's decreasing. This growth rate, 0.8, is less than 1. So when I graph this, I need to change the window. I don't want to change the x's yet until I see what it looks like, but I am going to change the y's. How high up? What do you think the y maximum needs to be if my y-intercept's at 300 and I'm going down? At least 300. Why don't we do like 350 so I can at least see the y-intercept? So we'll make it negative 10 to 350. And what do you want to make your scale? 25? 10s? It doesn't matter. Pick something here and hit graph. All right, can I see my picture better now? Okay. So, we graphed that function. Are we all okay with that? Like it told us to. Now it says use your graphing calculator or use the table in your graphing calculator to determine, I cannot talk today, how long it will take for there to be less than 10 milligrams of medicine in your blood. Well, how do I use the graphing calculator table to find that value? Scroll down until the y's are less than 10. And between what two numbers does it get less than 10? Between 15 and 16. So this would take between 15 and 16 hours for most of that medicine to go away. So we'll say, okay, it's going to be between 15 and 16. Now this is how we did it way back a couple weeks ago when we did modeling for our purposes. So we estimated. We looked in our calculator and said somewhere between 15 and 16 hours, we're going to be less than 10 milligrams and you'll have to take another dose of medicine. We also used our calculator to find the exact amount of time. So if I'm going to use the picture of my graph here to find that value, I need to graph one other line. And what other line do I need to graph on that grid? Y equals 10. So go ahead and let's type in y equals 10 to our y equals. Now we said that between what two x values were those going to cross that? 15 and 16. So I need to change my x scale so I can see 15 and 16 a little better. So let's go back to window. I'm going to start at 0 because we don't need the negatives, and I'm going to make my x max go up to 20. Just so that I can see a little better. And how did I find the exact time? We traced what part? Second trace. Which one did I choose? Intersect, number 5. And once I clicked on that, how many times do I hit enter? 3. 1, 2, 3. And it tells me exactly 15.242 hours is when I'm going to have 10 milligrams And after that, I need more medicine. Okay, are we okay with the calculator stuff? So 15.242 hours. Now, that whole top part, that is what we could do previously. Now that we've learned stuff on Friday, we can find this 15.242 by hand using algebra. And I know that you are just like dying to get to this part here. So let's see. If we're going to solve this algebraically, we need to set up an equation. So we're going to start by writing down the original equation that we wrote. 300 times 0.8 to the x. Now, what do we want to set that equal to? So, equals to 10. And we learned on Friday now, not only can I solve it on the calculator, but you now have the tools, I've had the tools, but you now have the tools to get that x out of the exponent. So what do you have to do first here to solve this? Do not take the log yet. Not yet. What do I have to move first? 300. I have to isolate the exponential, which means I have to divide by 300. I will take the log, but I have to move the 300 out of the way first. Does that 10 over 300 give me a nice fraction or a nice number? No, can you tell me the simplified fraction form then if it's not a nice decimal? 1 over 30. So I have 1 over 30 equals now 0.8 to the x. All right, and this is where we always got stuck before Friday because we did not know how to get the x out of the exponent. But what did we say to do on Friday now? Take the log. Remember, we throw a log at it. This is like our basketball. We throw a log at it. So what we're going to do is take the log. Natural log or common log here? Ooh, is there an E? Common log. So we're just going to write log of 1 over 30. And I'll do it the long way for this one. I'll write log of 0.8 to the x. Now remember, bless you, what logarithm law do we have? What happens to this exponent when I take the log? It goes in front. So what this really is x times log of 0.8. And remember, you can skip to that step if you want, but I wrote it out this time. Equals log of 1 over 30. And the only thing left to do is what? Divide by the log of 0.8. Now remember, when you type this into your calculator, you want to close all your parentheses. So you have log of 1 over 30, close your parentheses, divided by log of 0.8. And what do you notice about that number you got? It's the same as what the calculator gave you, right? So 15.242 hours. That's not what I wanted. I wanted this. Remember solving a little bit on Friday? All right, let's look at the page. Oh, no, we don't. There's one at the bottom. I'm sorry. I did that this morning, too. I forgot there's one on the bottom. Now, on Friday, I said these numbers were going to get kind of gross. This is one of them. So it says you deposit or put into a savings account $1,200, and the savings account earns 3% interest compounded quarterly. What formula do I use for compounded quarterly? Yeah, second to last. This guy right here. Now, so when you're doing percent change that's compounded by a set interval, this is the formula you're going to use. We want to know how long will it take that initial amount to triple. So let's fill in what we know. Do we know what this P, this initial amount is? How much? 1,200. All right, so that's our starting amount. And then we write our big set of parentheses here. It's always 1 plus. What's the interest rate as a decimal? 0.036. Now I'm dividing it by n. How many compounding periods are there if it's quarterly? 4. And my exponent is 4t. Do I know what t is here? No. No, because it says how long. That's saying what is t. I have to set that equal to something. This a that it's equal to. Well, it says we want to know how long until that initial value triples. So what's the triple of the initial value? 3,600. So I'm going to set those equal and then solve the equation. It's going to be just like the last one, Although that looks like a lot yuckier stuff I have to do with logs. All right, what's going to be your first step here? Get rid of the 1200. Divide that away. You cannot take the log until you move that 1200. You have to isolate the exponential. All right, so you'll have 3 equals that whole yucky or parentheses. It's not a fraction yet. That whole thing. Now, do not do not type this into your calculator, the quantity here in parentheses. Don't type it in and try to simplify it. Just leave it like that. Let your calculator do all the work for you later. What do you want to do next? Take the log of both sides. So I'll have the log of 3. And I guess I should have asked this. Is there a common base I can find between those two? No. That's why we're taking the log. So remember, when I take the log, that 4t comes down in front. And I have this whole yucky mess right there. Now, if I'm trying to get t by itself, what moves first, the 4 or the log? The log. So you divide by that whole log. And you still have not pulled out your calculator because you're being very patient with all of this writing you have to do. Ooh. Now, is it okay if I just erase that to save myself some writing here? Yes. Okay, so those logs go away. What's the last step you're going to have to do? Divide by 4. So what you're going to do is you're going to take the whole fraction of logs there in your calculator, hit enter, and then divide it by 4 and hit enter again. Now, if you have the ability to make this stackable fraction, go ahead and do that. If not, if you just type it like without extra parentheses, your calculator will read the order of operations correctly. So let's see, well, log of 3 divided by log of 1 plus 0.036 divided by 4. Enter, divided by 4 again. Does that seem right? Yes. Yeah. Okay. Now, what does that mean? 30.654. That means that's the number of years it's going to take. So if you put today $1,200 into a savings account, it's going to take you over 30 years to get $3,600. How old will you be in 30 years? In your 40s? Does that seem worth it? Not really. Yeah. So that's what that means. All right, we good? Flip the page now. There's a couple more. This next one, I'm just going to set it up. I don't think we're going to do the solving for log because I want to do another one, but we are going to start this problem. I don't know why it's highlighted in gray. Just go with it. How long does it take to double an investment if you can invest it at 0.92% compounded monthly? Now first, if I'm compounded monthly, which formula should I use? The second to last. Compounded monthly, we're set up in that second to last formula. Do I know what the initial investment is, this P? No. What am I looking for though? Am I looking for P or am I looking for something else? I'm looking for T. When it says how long, that means I'm looking for the T. So I am going to look for T, but I still don't know the initial value. So just put P for now. We don't know what that is. It's actually going to end up not mattering.
Could I just put a random number? Or?
Don't put a number. I mean, you could, but let's do it this way to start, and then we'll talk about if we need a number. So P equals 1 plus, what's 0.92% for R written as a decimal? 0.0092. How many compounding terms do you have? 12 to the 12t power. Now, even though I don't know what that initial investment was, we want to know how long it takes to double. So if I'm just calling my investment P, what should I write for its double on the other side? 2P. And here's why it doesn't matter if I know what the initial investment is. It's just like a hypothetical if I want to put some money in an account. What would I do next here? Divide by P. And what happens to the P's when I divide? They all go away. So you would be left with 2 equals that whole fraction. And I don't think I'm going to make you do the whole thing again here, but then what would you take of both sides? The log. So you would take the log of both sides. I'm going to put 12t in front. And then you would divide by log. And I'm just going to do dot, dot, dot here. Okay. Save this the last time. Is that okay? Yes? Okay. So you can leave it. You can finish solving that on your own in a little bit. All right. I didn't want to do two of the exact same typing things. All right. We're almost there. Let's do another one. Next one here. JZ. I don't know when we wrote this, but apparently JZ was popular. JZ takes $220,000 and he wants to invest it. Because, you know, he just casually has $220,000 sitting around. That was like some of your college debt, right, from your project. He has it sitting around. He wants $300,000 in 4 years. Right? I don't know what he wants it for. Maybe he wants to buy a fancy car, but he wants that much money. What annual rate of return or what interest rate will he need to find for his bank account to accomplish his goal? All right, so what are we looking for this time? What letter? When it says R. R. We are looking for R. So what R? That's what I want to know. I don't know what R is. Which formula am I going to use if he wants a bank account that compounds interest continuously? The last one. Pert. So let's figure out what we know. Do I know his P, his initial investment? How much is it? $220,000. Okay, now, after that P, the E is just a number, so you write the E. I don't know what R is. I don't know what his rate is, so I put an R. And how much time is he spending for this? 4, so it's R times 4, or 4R. What's his goal? What's his A on the other side? 300,000. Now this one's going to be solving essentially the same way, but we'll use a different logarithm here. What do I have to do first? Divide by 220,000, and that will give me a pretty nice fraction. Can someone do that math for us? 15 divided by 11. Okay, so you can leave it as that number. I would make it into 15 over 11. And now I have e to the 4r power. Now, because I have a base of e, what kind of logarithm am I going to use? The natural log. So go ahead and take the natural log of both sides. And what did we say on Friday was really nice about this natural log thing? What's the natural log of e? 1. And we said if you recognize the natural log of e as 1, it saves you time. Because you can just kind of cross it off and forget about it. What's the last step you have to do? Divide by 4. Divide by 4. Divide the whole thing by 4. And you get r equals, what's the natural log of 15 over 11 divided by 3? Yeah, so 0.0775. I'm going to go out to 4 here. Oops, I don't want that. Now that's a decimal. What percent is that? What interest rate is that? 7.75%. So JZ needs to find a bank account that will give him 7.75% interest compounded continuously to meet his goal. Are we good there? So there's a little bit of what'd you say?
Is that like really high interest?
It is very high interest. So a regular savings account, like if you just have a regular savings account at your bank right now, I think my savings account is less than a 1% interest. So it's very small for savings. Now, if you want a higher interest rate, there are special accounts that you can get that will have higher interest. Some of them are called certificates of deposit or a CD, or there are bank accounts for like really wealthy people that have really high interest rates, but you have to be able to put like a ton of money in it initially. You couldn't just put like your $1,000. But yeah, most savings accounts are like really small, like 1% or less interest, so you earn like a couple pennies every year. Yeah. But, yeah. Good. Cool. There's some practice on the next part. The formulas are from the front. This first one, the first one gives you the equation. The thing I want to talk about, though, flip to number 2 real quick. I just want to show, I'm not going to do this one with you. I just want to make sure, because some people in my earlier class were getting this wrong. It says a population of 50 through 5 is increasing at 8% per day. Now, does that say it's compounded every day? No. So do not use the compounding formulas here unless the word compounding is in the problem. There's no compounding there. Don't use the compound formulas. If this is just increasing by a percent, that's simply when you just add on the percent. Okay? So make sure you're looking for that keyword. Otherwise, the answers are on the back there. Go ahead,